Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com, SAAA, PAAS, and DAAS introduces 4 foundational delivery models used in cloud computing. These models define how services are packaged and delivered to organizations, and more importantly, they define who is responsible for managing which parts of the stack. Understanding these service models helps businesses align their technical needs with appropriate cloud solutions, whether they want full control over the infrastructure or just need access to ready-to-use applications. The choice of model has implications for cost, flexibility, support, scalability, and security responsibilities. The Network Plus exam requires a clear understanding of each model's definition, purpose, and real-world examples. You'll encounter questions asking you to compare models, select appropriate services based on business requirements, or identify which party manages specific layers of the service stack. These topics appear frequently in scenario-based questions, so being able to distinguish between what is handled by the provider and what remains under customer control is essential for making accurate decisions and earning exam points. Software as a Service, or SaaS, is the most user-facing of the cloud delivery models. It allows users to access applications directly over the internet without needing to install or maintain any local infrastructure. In SaaS, the provider hosts everything: the servers, the databases, the operating systems, the application code, and the updates. The end user simply connects to the service using a web browser or a thin client. This model is highly accessible and is designed for non-technical users who want to focus on productivity, not system administration. SaaS offers several benefits that appeal to businesses of all sizes. First, services are quick to deploy. Users can often sign up and begin using the application within minutes. Second, updates and maintenance are handled entirely by the provider, which means users are always working with the most current version. Third, the subscription-based pricing model aligns with operating budgets, allowing organizations to scale their usage and costs up or down based on demand. This flexibility supports both small teams and large enterprises. Despite its strengths, SaaS does come with limitations. Because the environment is managed by the provider, customization options are typically limited. Users may only be able to change interface settings or plug in pre-approved extensions. Additionally, all user data is stored on the provider's infrastructure, which raises concerns about data sovereignty, compliance, and backup procedures. Lastly, users are completely dependent on the vendor's uptime and performance. If the service goes offline, users may be unable to work until it is restored. Infrastructure as a Service, or IaaS, delivers virtualized computing resources over the internet, such as virtual machines, block storage, and network connections. In this model, the cloud provider manages the physical infrastructure, including servers, data centers, and networking. The customer is responsible for everything from the operating system up, including software installation, updates, and security hardening. IaaS is ideal for organizations that want more control over their environment, but don't want to own or maintain physical hardware. IaaS provides significant benefits for organizations with advanced technical needs. It offers full control over system configuration, allowing administrators to choose the operating system, install custom applications, and fine-tune performance settings. Because the resources are virtualized, computing power can be scaled up or down dynamically. IaaS is commonly used for development and testing environments, temporary computing needs, or hosting internal infrastructure in a more flexible and cost-efficient manner than building out an on-premises data center. However, IaaS also presents challenges. It requires skilled system administrators who are familiar with managing operating systems, configuring security, and maintaining uptime. Unlike SaaS, the burden of applying patches, monitoring for vulnerabilities, and configuring backups falls entirely on the customer. Costs can also become unpredictable, especially when resources are left running or network traffic spikes unexpectedly. Without proper monitoring and controls, IaaS environments can exceed budget quickly. Platform as a Service, or PaaS, provides developers with a complete framework for building, testing, and deploying applications without managing the underlying infrastructure. The provider offers a runtime environment, development tools, middleware, and pre-subjected databases. Developers simply upload their code and use the platform to launch applications. PaaS abstracts away the operating system and hardware, letting development teams focus solely on creating software. PaaS brings multiple benefits for developers and organizations pursuing agile development cycles. It accelerates application development by eliminating the need to set up and manage hardware or server environments. Platforms include features such as built-in scaling, load balancing, and automated patching. These capabilities reduce operational complexity and allow developers to concentrate on writing and refining their code. PaaS is well-suited for microservices architectures and cloud-net applications that benefit from rapid iteration and automation. There are some limitations with PaaS, particularly when it comes to control and compatibility. Because the underlying infrastructure and runtime environment are managed by the provider, organizations may have limited options for adjusting system-level settings or installing non-supported libraries. Compatibility issues may arise if an application requires a specific configuration not supported by the platform. Vendor-specific tooling and constraints can also make it difficult to migrate applications between platforms, leading to concerns about lock-in or reduced portability. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalscyber.com. Desktop as a Service, or DaaS, is a cloud computing model that delivers virtual desktops to end users over the internet. These desktops can be accessed from almost any device using a web browser or specialized client, allowing users to interact with a familiar desktop environment regardless of their location. In a DaaS setup, the provider hosts the desktop operating systems, manages the back-end infrastructure, and handles updates, storage, and connectivity. This model is commonly used to support remote workforces, temporary staff, or bring-your-own-device environments. DaaS provides several benefits for organizations looking to centralize and secure their desktop environments. It enables consistent user experiences across devices and locations while reducing the need for managing physical desktops. Security is improved because data resides in the cloud rather than on local devices, and access can be tightly controlled. Centralized desktop management allows IT teams to deploy updates, enforce policies, and troubleshoot from a single interface. DaaS also reduces endpoint complexity, making it easier to support a diverse set of user devices. When comparing the four service models, SaaS, IaaS, and DaaS, it's important to understand their unique focus. SaaS provides complete applications to end users, like email or customer relationship tools. IaaS offers the foundational computing resources needed to run virtual servers and configure custom environments. PaaS sits in between, providing development platforms without the burden of managing operating systems. DaaS replicates the traditional desktop experience through a virtual interface. Each model suits a different set of use cases and levels of technical control. Security responsibilities shift across these models. In SaaS, the provider handles most layers of the stack, including applications, middleware, and runtime environments. The customer typically manages user access and data usage. In IaaS, the customer assumes much more responsibility, starting at the operating system and moving upward. PaaS and DaaS share responsibilities between provider and customer. Understanding these boundaries is essential for applying security best practices and for identifying potential risks or misconfigurations in a shared responsibility environment. Each cloud service model fits different business types and workloads. SaaS is typically ideal for general office users who need productivity software, email, or collaboration tools. IaaS is more appropriate for IT departments or developers who need full control over their environments. PaaS is designed for software development teams that want to build and deploy code quickly without managing infrastructure. DaaS supports remote workforces and organizations with fluctuating staffing needs, providing flexible desktop access while maintaining centralized control. The pricing models also differ between these services. SaaS typically uses a per-user or per-licensing subscription, making it easy to predict costs based on user count. IaaS costs vary based on the number of virtual machines, storage, and network traffic, making resource monitoring essential to prevent overruns. PaaS and DaaS often use either flat-rate subscriptions or consumption-based pricing models, charging based on activity or allocated compute time. Understanding these cost structures is important for aligning budget expectations with cloud usage patterns. Vendor lock-in and integration flexibility vary across service models. SaaS solutions may limit data portability or customization, which can become an issue when switching providers. IaaS generally offers more integration flexibility, allowing the use of third-party tools, operating systems, and configurations. PaaS platforms may require the use of proprietary development tools or specific frameworks, which can reduce portability. DaaS environments often standardize the user experience, but may also limit customization based on the underlying infrastructure provider's capabilities. The Network Plus exam covers a range of cloud topics, including the distinctions between SaaS, IaaS, PaaS, and DaaS. You may be asked to match a specific scenario to the appropriate model, describe the level of customer control in each, or identify which party is responsible for system updates and security. A strong understanding of cloud models will help you navigate questions on cloud deployment, cost structure, service scope, and administrative responsibility. SaaS, IaaS, PaaS, and DaaS represent four essential cloud service models, each offering different levels of control, responsibility, and flexibility. Choosing the right model depends on your business objectives, technical expertise, and need for customization or scalability. From accessing pre-built software to building complex infrastructures and deploying desktop environments, these models provide a range of solutions to meet both operational and strategic goals. Understanding these models prepares you for both exam success and real-world implementation of cloud services. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.